Okay. Let us look at another problem, okay, so that we can get familiar with some of these problems. Okay. Here let us say the rod AB is rotated, link AB is rotated by moving this bar or block along a slot. Okay. This slot is actually fixed to the fixed frame. Okay. So, this can move up and down whatever, and we need to find out the angular velocity of AB. Okay. Is the geometry given? Yes, at a particular location, at a particular configuration of this, let us say the quantities are given. What are the quantities? The length of AB, the length of BC and the angle at the instant of what we want to find out, let us say are given, which means the entire geometry is given. The direction of VC is fixed, as you can see here. This is the constraint. If you can identify the constraint number 1, what is that? Direction of VC is vertical, that is something we know. Okay. The velocity of this is let us say given, we will come to that. Well, before that we will identify the constraints. Okay. What is the other constraint? Constraint number 2 is, if you look at this point A, it is fixed to the fixed frame. So, VA equals acceleration of A equals 0, correct. That is another constraint given. Any other constraint? If you look at B, the constraint of B is such that the velocity of, so that is the next constraint, constraint 3 that connects these two bodies. Okay. What is that? Velocity of B with respect to seeing BC should be the same as the velocity of B as I see from AB. Okay. It is true with acceleration also. Okay. Once I understand these constraints, now it is very easy. Okay. I need to find out, let us say, the angular velocity of rod AB. How will I go about? Very simple. This has an angular velocity, which means what? This particular point will be moving like this. Do you get this? This is horizontal, this will be moving vertically upward. Okay. So, let us look at BC, alright. BC is like this, this direction is given to be like this is BC, alright. What do we know about this point B? Looking at AB, it is perpendicular to the direction AB, right. So, which is this direction. What is the value of this velocity at B? What do you know about that? Very simple, we did this in the tip number 7 or 8, I do not remember. If this direction is known and this direction is the same as this direction, what will be the velocity of this? Is the same as velocity of this. So, immediately I will write VB velocity is equal to VC velocity. In fact, I can remove this because the direction was also same, VB and VC move parallelly at this configuration. Please remember that it is at that configuration that I am talking about. Okay. Now, it is very simple, VB is given to you. How do I find out omega AB? That is very simple, omega cross RAB is omega AB, okay, and problem is solved immediately because R omega times this direction is equal to VB is equal to VC. Is this given? The answer is yes. So, R omega is given, R is known, omega can be found out. Okay. Just to make it very clear, RAB times omega AB. look at the way in which we have solved this problem. We are looking at it in a very simple way and trying to see if we can solve the problem. Okay. If the velocity is downward, I should assume a downward direction here. Notice that this is actually r omega w, r omega in the upward direction. If I have to equate it to downward direction, I will have a negative sign coming in, or in other words omega will become clockwise instead of anti-clockwise. Okay, signs will automatically match the moment I have the directions properly understood. Remember, if it is rotating like this with an angular velocity omega b, the velocity of Vb will be along this and the direction is omega r times this direction. Clear? It is as simple as that.